Hello, welcome back to our very new channel. We are here today to know about the Big Bang and what was it and when did the universe begin and how was it like when the Big Bang happened. And at the first of all, uh, while we are supposed to learn about the Big Bang, we have to know that when did the universe begin? Scientists have argued about this for centuries, and as for now, today, even the theory is still not proved completely. But yeah, this is the most probable theory which is given about the origination of the universe. At the moment, most people agree that the universe began between 12 to 15 billion years ago. Remember this point that 12 to 15 million years ago. It all started with a mind-boggling explosion called the Big Bang. And as we know about that what was the Big Bang. We should know that it was a huge explosion, a very, very huge explosion that created all the mass and energy in our universe in less than a second. The effects of the blast are so strong that the universe is still expanding. This means that the explosion, the Big Bang, was so super massive that the universe is still expanding because of its effects. Now, here we come for the expansion of the universe. So, at the first of all, we should know that who gave the theory of expansion of the universe. The astronomer Edwin Hubble used a 100-inch telescope on Mount Vinson, California, to study the night sky. He found that some of the nebulae, fuzzy luminous specky in the night sky, are in fact galaxies, like our Milky Way. Although the galaxies could be widely varying in sizes, each containing billions and billions of stars. And he discovered a remarkable fact: other galaxies appear to be moving away from us, and the further they are from us, the faster their apparent speed. Suddenly, humanity's universe became much, much larger. The universe is expanding, distances between galaxies are increasing with time. The universe can be thought of as the surface of a balloon on which one has painted blobs to represent the galaxies. If one blows up the balloon, the blobs of galaxies move away from each other. The further apart they are, the faster the between that increases. So, I think that the concept of expansion of the universe should be clear by this lecture. But yeah, here comes the redshift. The redshift, first of all, we should know that what is redshift in such simple language. Very hot objects in space like stars produce visible light. As we all know that the stars, any star like every single star produces visible light, produces photons. But as the universe is constantly expanding, these distant stars and their home galaxies are moving away from Earth. I think that it should be cleared, but yeah, if you still don't get it, so there's no problem. It's like the stars which are there, every single star produces visible light. Like if we see it as the universe is constantly expanding, the distant star like Betelgeuse, as that's a very supermassive star, which is at least 8 times bigger than our sun. So uh, the Betelgeuse is moving away from the sun, like if we take it as an example, is moving away from the earth and the sun. There stretches their light as it travels through space towards us. Or this stretches their lights. This means that the light produced by the Betelgeuse, for example, is moving away from the sun. So the more stretched it becomes, like how can I explain this? The more stretched it becomes, yeah. The stretching makes visible light look redder. Which means that the Betelgeuse, which is producing light, is becoming redder, more red in color because of the redshift theory, as the distance of these two stars, for example, the Sun and Betelgeuse, are moving away from themselves, which is known as the cosmological redshift. So now that we are here through the subject of the redshift and the expansion of the universe and what was the Big Bang, and now we go to Big Bang deeply, as we are about to know about it. That the suppose you are sitting inside the universe at the very early time, about 12 to 15 billion years ago, where Big Bang was about to happen or has already happened. Obviously you cannot sit outside of the universe. So you would have to be very tough, because the temperatures and the pressures inside this Big Bang are so tremendously high. Back then, all the matter that we see around us today was squeezed into a region much smaller than an atom. So, at the time of the Big Bang, all the matter, all the atoms, electrons, photons, for example, which we see around us today, which is obviously photons are coming from your screen on whichever screen you are watching this on. So, and temperature, it was these all were squeezed into a region much smaller than an atom. It means that much smaller than an atom. This would be a tiny fraction of a second after the Big Bang, and but everything looks much the same in all directions. There's no fireball lashing outwards. Instead, there is a hot sea of material um, filling all of the space. And you should mind, you would be minding that what is this material? Because we are not certain. It may be particles of a type which we can see it